Water. We know that nearly two-thirds of the Earth's surface is covered with water. Water is one of the most essential substances for the existence of life. All living beings need water. Occurrence of water. Water is present in all three states of matter. In solid state, it exists as ice, snow, and frost. In liquid state, it occurs as river water, well water, lake water, and dew. In gaseous state, it occurs as water vapor, clouds, mist, and fog. Water is present in all living matter, plants, animals, and human beings. Nearly 70% of our body weight is water. Water is present in all fruits and vegetables. It is even present in the things that look dry, for example, peas and oat. Importance of water. It is used for bathing, drinking, cleaning, and cooking food. It is necessary for the growth and development of the living beings. It acts as a medium for different biochemical processes in the cells. It regulates the body temperature by sweating. It is necessary for the germination and growth of plants and photosynthesis. It is used for growing crops. It is habitat for some living organisms, aquatic plants and animals. It is used in industries for various purposes. It acts as a coolant in nuclear reactors and car radiators. It is used in laboratories to do experiments. It regulates the climate on the earth. It is used for generating electricity in hydroelectric power plants. Source of water. There are many sources of water: rainwater, surface water, and underground water. Rainwater. Rainwater is the purest form of natural water. We get rainwater from the rain. It is formed by continuous evaporation and condensation process in the atmosphere. It contains dissolved gases like oxygen and carbon dioxide. The first shower of rain collects dust and germs present in the atmosphere. Thus, it also contains impurities. However, the later showers of rain are free from impurities and thus is good for drinking purposes. Surface water. The water present on the surface of the earth is called the surface water. River and lake water, ocean and sea water. So river and lake water. Waters in rivers and lake come from rain and melting of snow on the mountains. Water flows down the mountains and go into the rivers. On its way, it dissolves some soluble salts and carries suspended impurities like sand, clay, and twigs. It also contains waste materials that are discharged from the rivers by the factories. River water may also contain germs. These germs may cause various diseases like jaundice, dysentery, cholera, and typhoid. Therefore, river water cannot be used for drinking purposes directly. Ocean and sea water. Ocean and sea are the largest source of water on the earth. They contain a large amount of dissolved salts, mainly common salt. Due to the presence of common salt, it is salty in taste and is called as saline water. Sea or ocean water is not fit for drinking and irrigation because of its ice saline nature. Underground water or subsoil water. The reservoir of water collected over the hard non-porous rocks below the surface of earth is called the groundwater or groundwater. The level of groundwater is called the water table. The groundwater is pumped out by digging wells. Hand pumps and tube wells are used to pump out groundwater. The groundwater is used for households, agriculture, and industrial purposes. Springs are also a source of underground water. This water contains dissolved impurities but not suspended impurities or germs. Water cycle. The continuous movement of water from the earth's surface and the water bodies in the form of water vapor to the atmosphere and the form of atmosphere back to the earth's surface as a rain, hail, or snow is called the water cycle. The water cycle maintains the supply of water on the land. It also regulates the weather on earth. The three main processes that are involved in the water cycle are evaporation, condensation, and precipitation. Evaporation. The heat of the sun evaporates water from the water bodies like oceans, seas, rivers, lakes, and ponds. Plants also give out water vapor through the transpiration. Water vapor are also continuously added to the atmosphere by the continuous process of respiration by animals and plants and burning of fuels. Second, condensation. At higher altitudes, the air becomes cold and the water vapor present in the air condenses to form tiny water droplets of water. These water droplets, along with the dust particles, form clouds. The tiny water droplets in the clouds come close in to form a big water drop. Precipitation. Water from the clouds falls as rain, hail, or snow. This is called the precipitation. The rainwater collects in the seas, oceans, and rivers and lakes. This cycle continues again as evaporation, condensation, and precipitation. Water and compounds. The nuclear formula for water is H2O. The chemical name is dihydrogen monoxide, and nuclear mass is 18 mmol. One molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen. The ratio of hydrogen and oxygen in water is 1:8 by the mass. When an electric current is passed through the water, acidulated water, it breaks down into the constituent elements oxygen and hydrogen. 2H2O is equal to 2H2 plus O2. Physical properties of water. Nature. Pure water is colorless, tasteless, odorless, and transparent liquid. Boiling point. The boiling point of the pure water is 100 degrees Celsius under normal pressure of 1 atm and 760 mm of hydrogen. Change in pressure and addition of impurities affect the boiling point of water. When non-volatile impurities or salts are added to it, its boiling point increases. When pressure is increased, the boiling point increases and vice versa. It is easier to cook food in pressure cooker than in an open vessel. It is because when the pressure increases in the pressure cooker, the boiling point also increases. Hence, the food inside the pressure cooker gets sufficient heat before the water boils. This makes the food easier and faster. In hilly areas, the atmospheric pressure is low, less than 1 atm, so water boils at lower temperature, less than 100 degrees Celsius. Thus, it takes a longer time to cook in hilly areas. Freezing point. The freezing point of pure water is 0 degrees Celsius under normal pressure of 1 atm or 760 mm of hydrogen. Change in pressure and addition of impurities affects the freezing point of water. When pressure is increased, its freezing point decreases and vice versa. When impurities like salts are added to the water, its freezing point decreases. You might have noticed sprinkling of salt on ice. It is done to delay the melting of ice. Salts lower the melting point of ice and thus it can keep the ice for a longer period of time. Density. The water has maximum density and minimum volume at 4 degrees Celsius. The density of pure water at this temperature is 1 gram and 73 cube. Conductivity. The pure water is a bad conductor of heat and electricity. Water conducts electricity only when some impurities like salts or gases are present in it. Specific heat. The amount of heat required to increase the temperature of a unit of substance by 1 degree Celsius is called the specific heat of substance. The specific heat of water is high. It is 4.2 gaulows or grams or degrees Celsius. High specific heat means water needs more heat to become hot. Also, it needs more time to lose heat, that is, to become cold. In other words, we can say that water neither heats up nor cools down quickly. Water is an excellent cooling agent because of its high specific heat. It is used as a coolant in car engines, nuclear reactors, and machines. It absorbs heat and prevents overheating. Anonymous expansion of water is the last physical property of water. We will see about this topic tomorrow. So, thank you friends. See you tomorrow with a new topic. Bye.